Let's now actually go ahead and solve a differential equation by using this annihilator approach. We'll start off as we have throughout this middle of this chapter. The first step will be to find the complementary solution. So we're going to find y sub c, and that is found by solving the homogeneous differential equation y double prime plus 3y prime plus 2y equals to 0. The auxiliary equation for this would be m squared plus 3m plus 2 equals to 0. That auxiliary equation factors as m plus 2 times m plus 1 equals to 0. Set each factor equal to 0, and we get m equals to negative 2 and m equals to negative 1. Therefore, the complementary solution is going to be c1 e to the negative 2x plus c2 e to the negative x. So that's step 1. Step 2 will be now trying to find the particular solution, y sub p, and that's going to begin by finding an annihilator for the function g of x. Okay. So we want to find an annihilator for g of x. And the differential operator of lowest order that would do this would be the third derivative. So d3 annihilates, total misspelling, annihilates 4x squared, meaning that when we apply the third derivative to 4x squared, it's going to be equal to 0. So we're going to take this differential operator, d cubed, and then apply it to both sides of our original differential equation. But before doing so, let's go ahead and write that original differential equation in operator notation. It's y double prime plus 3y prime plus 2y. That's the second derivative plus 3 times the first derivative plus twice the original function. And this is equal to 4x squared. To this, we're now going to apply d cubed. And here's what we get. This is going to be d cubed. I'm going to go ahead and put this in factored form. We already factored this as d plus 2 times d plus 1 times y equals to, now because that annihilates the right-hand side, this right-hand side is equal to 0, which means that this is now a homogeneous differential equation. So we can solve it much in the same way we solved the first step of this problem. We can form the associated auxiliary equation. It's m cubed plus m times 2 times m plus 1 equal to 0. We set each factor equal to 0. And we get the following values. We get m equals to 0, which is a 0 of order 3, because we have m as a factor 3 times. We get negative 2, and we get negative 1. So what that would tell us about our solution is that it would look like this. I'm going to write these two first. Is we're going to have some constant times e to the negative 2x plus some constant times e to the negative x plus, then we're going to have some third constant plus some constant times x plus some constant times x squared. So that's what our general solution is going to look like. For the particular solution, what we noticed that if we look at some of this part that we have here, there's already some overlap with our complementary solution. Namely, the constant times e to the negative 2x and the constant times e to the negative x, that portion of it was already included in the complementary solution. The part that's missing, or the part that would be a portion of the complementary solution, of the particular solution, would be this part right here. c3 plus c4x plus c5th x squared. And we're going to solve for those undetermined coefficients. Just to make the notation a little bit nicer, let's call them a, b, and c. So we want to solve for the coefficients a, b, and c such that y sub p would be a solution to the non-homogeneous differential equation. To solve for that, we're going to plug y sub p into the differential equation. So we're going to need the first derivative and also the second derivative. Let's go ahead and plug it in. So it's y double prime, that's going to be 2c plus 3 times y prime, which is b plus 2cx plus twice y, which is a plus bx plus cx squared, and this is supposed to be equal to 4x squared. Let's eliminate the parentheses. So just distributing. We're going to combine our like terms on the left-hand side. We have a 2cx squared. The terms that have an x with them would be these two here. So it's going to be a 2b plus a 6c times x. And then these remaining ones would be our constant terms. We have a 2a, a 3b, and a 2c, and this is supposed to be equal to the polynomial 4x squared. Via equating coefficients, we get the following system. So 2c will be equal to 4. There is no linear term on the right-hand side, so 2b plus 6c will be equal to 0. And there's no constant term either, so 2a plus 3b plus 2c will also be equal to 0. Divide by 2, we see that c is going to be equal to 2. We can plug c into the second one to get that 2b plus 12 equals to 0. That will apply that b equals to negative 6. And if we plug both of those into the last equation, we're going to get 3 times negative 6 would be negative 18 plus 4 equals to 0. 2a minus 14 equals to 0. And that will apply that a equals to 7. And that gives us our general solution. So remember, it was the complementary solution, which was c1 e to the negative 2x plus c2 e to the negative x. And now our particular solution, we know the value of it. A is 7, so that's plus 7. B is negative 6, so it's negative 6x. And then plus 2x squared. And so there's our general solution. We found it via solving the complementary solution first. We then found an annihilator for the function g of x. And in this section, g of x will always be one of those functions of the form that's presented. So we'll be able to easily find an annihilator for it. We apply the annihilator to both sides of the differential equation. We solve the auxiliary equation from that part, and then proceed to solve for the undetermined coefficients to get y sub p.